So this is a National 4, National 5 chemistry lesson on the subject of bonding, and this lesson in particular is about two types of covalent bonding. So your aim is to identify and describe different types of covalent bonding, and the success criteria would be to state the different types of covalent bonding, describe the difference between types of covalent bonding, and identify different types of bonding through diagrams. So in terms of types of covalent compounds, we have two types. We have covalent molecular and covalent networks. All the molecules along the bottom are covalently bonded molecules that you have seen before. So methane, which has a tetrahedral structure, water, which has an angular structure, and carbon dioxide, which has a linear structure. They are all molecules, and so they come under the category of covalent molecular. However, there are other types of chemicals or compounds that exist which have a covalent network structure instead. So covalent molecular and covalent molecular are small, discrete molecules. Now, by discrete, what that means is that you could look at it as one thing. You could identify that is a single molecule of methane. That is a single molecule of water. You could make a model of it and it would represent the whole thing. That means they're small and individual. So methane, water, and carbon dioxide are all small, discrete molecules held together by covalent bonds. Now, most substances that contain covalent molecular bonds have low melting and boiling points, which means that they are most likely to be a liquid or a gas at room temperature. So all the molecules from the previous slide, methane is a gas, water is a liquid, and carbon dioxide is a gas. So all things like water, oxygen, carbon dioxide, chlorine, and hydrogen have low melting and boiling points, but why? And this is because the covalent bonds within the molecule are really strong. That covalent bond being the attraction between the two nuclei, positively charged nuclei, and the shared electrons. That is a really strong bond. But if we look at water, for example, if we put one water molecule beside another water molecule, there's nothing stopping you from pulling them apart from one another. You could separate one water molecule from another. And that means that it's weak and easy to break them apart. And that's what we're looking at. Whenever you're melting something or boiling something, that's you trying to pull one molecule away from another molecule. And where you have molecular covalent bonding, that's very easy, which means that you have low melting and boiling points. So this is water, and the thick lines are the strong bonds within the molecules, and those are covalent bonds. And it's really difficult to try and actually break a water molecule into something smaller. However, as I said, between the water molecules, if you put one water molecule beside another, it's very easy to pull them apart, which means that the bonds between different water molecules are weak. And that's what we see with molecular covalent compounds. Now, we also have another type of covalent compound called a covalent network. Now, covalent networks have two names. They can be called covalent networks, or sometimes they're called giant covalent lattices. What a lattice means is that you've got a pattern that's repeating over and over and over again lots of times. So if you ever hear the word lattice, that just means a repeating pattern. And a covalent network is a repeating pattern of the same bonds and the same atoms over and over and over again. So an example is silicon dioxide. And if you ask your chemistry teacher in school, they probably have a model so that you can see it in much more detail than this diagram, because this diagram only shows a very small part of the network. When we're talking about a network or a giant covalent lattice, we're talking thousands, if not millions or billions of covalent bonds, all holding the compound together. And if we've got so many covalent bonds, it becomes very, very, very difficult to break the compound apart. So silicon dioxide, this is an even clearer diagram, so you can see that it's a really big network, and this again is only part of it. That keeps going on and on and on and on and on. And there are other types of covalent compound. We have diamond, which looks quite similar to silica or silicon dioxide. And we have graphite. Now graphite is what you would find in a pencil lead, and it's the same chemical. Diamond and graphite are the same element, they're both carbon, but the way that they form makes them different. Diamond has a lot more bonds, making it a stronger lattice, a bigger network, so it's very, very strong, whereas graphite is not as strong because there are less bonds. And one of the properties of any covalent network is that because you have a large number of strong covalent bonds, covalent networks have high melting and boiling points. It's very hard to melt diamond, it's very hard to melt graphite, and it takes very high temperatures to melt silicon dioxide. And the reason why they have high melting and boiling points is because in order for diamond to melt, you need to break all of the bonds between the carbon atoms. And that is going to take an awful lot of energy to do. So covalent networks have high melting and boiling points. Covalent molecules have low melting and boiling points. So you should now be able to state the different types of covalent bonding: molecular covalent and giant covalent or covalent lattices or covalent networks. Describe the difference between the types of covalent bonding. So covalent molecular are small, discrete molecules where there are strong bonds within the molecule, but between molecules there's a very weak bond. And then for a covalent network, you've got lots and lots of repeating strong covalent bonds that hold it together very tightly. And you should be able to identify types of bonding through diagrams. So a covalent molecule, you'll notice, tends to only have maximum at National 5, maybe 6 or 7 atoms in it. Whereas a network, a covalent network or a covalent lattice, you will see lots and lots and lots of repeating bonds over and over again. And also, you know the difference in properties. Covalent molecules have low melting and boiling points. Covalent networks have high melting and boiling points. So now what we'll do is look at some revision questions. So this question is from a past paper and it's asking you to circle the words that will complete the sentence. So a covalent bond forms when two nuclei, and the nuclei might be positive, negative, or neutral, are held together by their common attraction for a shared pair of either protons, neutrons, or electrons. Well, it should be positive nuclei, two positive nuclei, with their common attraction for a shared pair of electrons. So this is another type of question. So firstly, name the type of bonding and the structure present in diamond. And secondly, draw a diagram to show a molecule of methane. So firstly, diamond is a covalent lattice. So to get the mark for that, you needed to say that it was covalent and that it was a lattice or a network. For your structure of methane, you could have drawn an electron cloud diagram, that's the one on the right, Or you could have drawn your normal dot and cross overlapping circles diagram on the left. You needed to show that you had 4 hydrogens and 1 carbon, and that each time there is an overlap, 2 electrons are shared, 1 from the hydrogen, 1 from the carbon. Now this one is not asking you to draw an orbital diagram. It's not asking you to draw any electrons. It's asking you to draw using bonds the shape of a methane molecule. So you need to show the shape. So it cannot look like a flat. You have to try and draw it in 3 dimensions. And so for methane, it is this. So you wanted to show that there's 1 hydrogen pointing up and 3 pointing out. You could have labeled it as being a tetrahedron, and you could have also used wedges and dashed bonds in order to show that one of the hydrogens was pointing towards you and one of the hydrogens was pointing away from you. But as you can see, you were allowed to just use normal bonds for that as well. So that concludes our comparison of molecular and covalent bonds. I will catch you next time where we look at different types of bonding.